Hello everyone, welcome back to CSE 151A. This is lecture 2. We're going to start by talking about what is machine learning. And before we get into that, I have a few announcements. The first homework will be published this evening. It'll be due next Wednesday before midnight via Gradescope, and it'll only cover today's lecture and a little bit of a probability refresher. So it'll be a shorter homework. So computers are great because they can do things very quickly. They're fast. But the problem with computers is that they're kind of dumb. We have to tell them exactly what we want them to do. We have to give them very specific instructions in the form of algorithms. And the problem that we run across is that not all tasks are easy to dictate. Here's an example of a problem which is easy, that of finding the shortest path between two nodes in a graph. It's easy because we can tell a computer an exact, precise algorithm for solving this problem. That algorithm, of course, is breadth first search. Now contrast that problem with the problem of determining a person's age given an image of their face. Now, you and I probably could guess reasonably well what this person's age is. I mean, I'm going to say maybe lower 60s. But imagine trying to tell a computer exactly how you came to that conclusion. Honestly, I'm not too sure how I came to that conclusion. The best I can figure is that I know people who are 60 years old, and this person looks similar to them in some respects. So if I don't even know my own internal algorithm for answering this question, how do I even start to get a computer to answer it? The approach we take in machine learning is to sort of abandon all hope of telling the computer how we come to our conclusions. Instead, we give the computer a bunch of data and we give it the right answers. So for example, we might give it a bunch of faces, and for every face, we tell it the age of the person in the image. And our hope is that the computer will be able to pick up on the important differences between people in different age groups, and therefore sort of learn on its own how to guess someone's age accurately. So in sort of the classical computer science setting, we tell the computer how to solve the problem by giving it an efficient algorithm. In contrast, in machine learning, we don't tell the computer how to solve the problem. The computer learns how to solve the problem. Now, you might be thinking, something's got to give here. We have to tell the computer how to do something. And that's right. We have to tell the computer how to learn. We have to give the computer a specific set of instructions for learning. That is, we have to give it a learning algorithm. Now, you might think learning sounds complicated, so these learning algorithms are probably going to be complicated too. But the surprising thing, it turns out, is that the learning algorithms are actually pretty simple. It's the data that kind of does the magic and makes machine learning work. There are a whole bunch of machine learning tasks. The first one that we've already talked about is prediction. For example, given an image of someone's face, predict how old they are. Second is clustering. Clustering is trying to automatically find the natural groups in a set of data. So the word cluster right now, you may have heard of it in relationship to, COVID-19, trying to find groups of people who have the disease. Representation learning is about taking some data in sort of in the format that is given to you and learning a new way of representing it that might be better, for example, for visualization or for plugging into another machine learning algorithm. Reinforcement learning is a technique used a lot in artificial intelligence. It's about trying to get a machine to perform well at a certain task by giving it feedback. Anomaly detection is about determining if a new piece of data sort of comes from the same distribution as our old pieces of data. And there are many more machine learning tasks. In this quarter, we're going to talk about prediction, clustering, and representation learning. And we're going to spend the first 5 or 6 weeks talking about prediction because it's probably the task that comes to mind whenever you think about machine learning.